In this video, we will tackle our example looking at the ice cream situation, look at differences and what that really means, as well as finally actually do the paired confidence interval. So in our example with the ice cream, we're now going to take a random sample of 31 people, and we ask them to dish up 2 bowls of ice cream to serve to people. We gave them 1 medium bowl, which was 9 ounces in size, and 1 large bowl, which was a 12-ounce size. We then measured the amount of ice cream in each bowl, which was also measured in ounces. So let's talk through why this example will be a paired sample. So our 2 groups that we're comparing are the large bowl to the medium bowl. And so we're going to have someone dish out a bowl of ice cream. And suppose that this was Quinn's large bowl. Well, so now Quinn is also going to have to dish out a medium bowl as well. Right, so each person is dishing out both bowls, so that's why this one is going to be paired. So that is what makes this one paired, because each person is dishing out that large and medium bowl. So here we're going to want to calculate the difference. So here the difference was calculated as the large bowl minus the medium bowl. For this example, I do also have the data that you need on our Canvas page. So I'm also going to first pull that up onto StatCrunch here for us. So I'm going to upload my data set. So that we can actually look at the numbers here first. So for each of our 31 people, we have the amount of ice cream they put in the large bowl, the amount of ice cream they put in the medium bowl, and then the difference where it's the large bowl minus the medium bowl. So here I can actually see the individual ice cream amounts, but what I really care about are these differences. To get the values you see here from StatCrunch, I'm going to first create my histogram of those differences. So there's that histogram. But again, so this is not of the ice cream amounts, but in the differences in the ice cream amounts. Then to get the mean and other information, we go to Stat, Summary Stats by column for those differences as well. So here we got a lot more numbers than the ones that we were provided, but we have all the numbers as well, just rounded to some slightly different values here. So that's what we did. So looking at those differences. What you'll notice from both the histogram as well as the numbers themselves is that we do have some negative numbers. Those resulted when someone put actually more in the medium bowl than they did in the large bowl. But the majority of our numbers are positive because they put more in the large bowl than in the medium bowl. So that key number of 0 is important here for us. So we're going to first go through those 4 characteristics that we've done before when we've had a histogram in summary statistics. So we're going to describe our shape, outliers, center, as well as the standard deviation. So let's first describe shape after we get the context going here. So when looking at the difference in ice cream amount, and again, so we did large minus medium. Looking at the graph, hopefully we would describe it as unimodal. Now, does it look like it's skewed left, skewed right, or pretty symmetric? Well, it's definitely not perfect, but it does actually look pretty symmetric. The mean and median being so close to each other also helps me confirm that it's roughly symmetric. So if I have a graph that is unimodal and pretty symmetric, that should hopefully make me think of that normal bell-shaped curve then when I see it. Now, are there any outliers? Probably these over here. So there are 2 outliers who put 2 ounces more in the large bowl. How do I know it was 2 and not, for example, 2.25? Well, I was also provided the maximum value here, which was 2. That's why I knew it was 2. Now let's describe our center. So first, our mean. So on average, the mean is 0.6935. But again, that's not the amount of ice cream. That's the difference in amount of ice cream. So what does that tell me? So on average, there was 0.6935 ounces more put in the large bowl than in the medium bowl. Now our median tells us that half of those sampled put 0.7 ounces. We'll just say at least 0.7 to make this feel a little bit better. More in the large bowl. All right, finally, I'm going to want to interpret that standard deviation. So we start at our mean of 0.6935. We go out 1 standard deviation in both directions and get so then I can say that our typical ice cream disher put between 0.1191 ounces and 1.2679 ounces more in the large bowl. Than in the medium bowl. So it looks like it seems that people are putting more in the large bowl than in the medium bowl. That was not true for everybody because we did have some negative differences here as well. So this again has really just been to understand what the differences are. Now we'll actually do the confidence interval. So we're going to construct a 95% confidence interval to estimate that average difference in ice cream amount. So our first step is always to define our parameter. Here it's not just mu, but it's going to be mu sub d to emphasize that difference. So this is going to be our population mean difference in ice cream amounts. Technically that was measured in ounces, if that's helpful for us. Also, our order of subtraction was large minus medium. It can be very helpful to actually pause here for a moment and think about what a positive versus a negative versus a 0 as a number would mean here for us. So if we got a positive number, that person put more in the large bowl than in the medium bowl. If we got a negative number, they actually put more in the medium than in the large. And if we were to get 0, that would tell me they put the same amount in both bowls. That's going to be very helpful for me later. Once I'm done with the calculation, I have these numbers that I'm trying to make sense of. Our second step is our conditions. So I need to have a dependent sample, which we already discussed in part A, why it was dependent. We still also need to be a relatively random and unbiased sample. It just said that they took a random sample of 31 people, so it did not really tell us too much about how they chose those 31 people. But from what at least we know, there's nothing bad about that. Then we either need our differences to be normally distributed or to have sampled at least 30 people. In this case, actually both of these is going to be true. Let's talk through this differences being normally distributed first, because that is technically what this histogram is giving me, and I described its shape as being unimodal and symmetric. So if my graph is unimodal and symmetric, I should feel comfortable in saying then that my differences here are normal. So my histogram was unimodal and pretty symmetric. Technically in this case though, both of them is true because we've also sampled 31 people. Again though, this just has to be an or. They do not both need to be true. They also just happen to both be true in this example. And then finally, that population standard deviation of the differences is going to be unknown. We do actually have the sample standard deviation of the differences. That is what this sample standard deviation is that was given to us here. So that's going to be that 0.5744 is this SD. For step 3, we're going to be doing our confidence interval calculation. And one of the first things I'm going to need is actually my t from my t-table. So let's go ahead and pull the t-table up as a reminder. So our t-table needs to know our level of confidence as well as our degrees of freedom. Now in the question, it's told us to do 95% confidence. And my degrees of freedom are also just n-1 like we had before. So we have 98% confidence. Our n was 31, so we're going to have 30 degrees of freedom once we subtract off the 1. And we should find the 2.042 right here for us. So there's our t that we're going to use. So now we have everything to plug into our formula that we have at the bottom of page 3. So our sample mean difference is from the StatCrunch output will be 0.6935. We just found our t. We labeled our SD back in the conditions as well as our n. So we already have everything we need here to do the math. So we take our 0.6935 minus our t times our SD over the square root of n. And then the same thing on the other side, but with a plus sign between them. Now again, it's just more of making sure you do your order of subtraction and order of operations here correctly. So I'm going to be doing what's in parentheses here first. Which should give me 0.103165. And that's going to give me the same thing here on the other side. Now we'll do our multiplication. And get 0.2107. And then finally our subtraction and our addition. So there is the math all the way done for us. As a quick reminder of some old terms that we've learned, when I did this calculation of the 0.5744 over the square root of 31 and got this 0.103165 number, another name for this is what we call that standard error. And then once I multiplied that by my t and got this 0.2107, this is what we would call again our margin of error. So similar terms to what we've seen for other confidence intervals. The last thing that we want to do is interpret this. And we're going to follow the same form as we did before, but now maybe you can see why writing this out up here is helpful for us. My entire interval was positive, telling me they put more in the large bowl than in the medium bowl. So this is going to help me for interpretation. So since this is all positive, I'm going to be able to say they put more in the large bowl than in the medium bowl. But not only can I say that they put more in the large, I can tell you how much more they put in the large bowl. So now I can say that I am 95% confident that the mean amount of ice cream put into large bowl is between 0.4828 and 0.9042 ounces more than into medium bowls. So you'll see that this interval is different than the one we constructed earlier when we were looking at the typical value here. When we did the typical value, we got 0.1191 to 1.2679. But remember, when we do this summary information, this is looking at individual ice cream dishers. However, when we do a confidence interval, we are now looking at where the mean amount of ice cream falls. So now when I look at this, it does look like there's a psychological effect and people are putting more in the large bowl than the medium bowl because the average amount is almost at least a half an ounce higher in the one versus the other. In the next video, we're going to explain the StatCrunch output and demo how to get that output.